The next topic we're going to look at for vectors is direction angles. A direction angle is the angle that the vector makes with a horizontal line. So when our vector is in standard position, theta is our direction angle, and we can link it to the unit circle because the x component will be cosine of theta, just like for the unit circle, and the y component will be sine, just like the unit circle. Another way to express this is using those unit vectors I and j and simply multiplying your cosine by I and the sine by j. That's if u is a unit vector. If v is a vector that's heading in the same direction but is not a unit vector, then you simply take the magnitude of v times the cosine and sine components, and then you can see that expressed with the unit vector form as well. Our first example will be finding magnitude and that direction angle for vector u, which is 3i plus 3j. We know the component form of u is 3, 3, so we can easily find the magnitude of u using our distance formula. Remember, the shortcut when your vector is in component form is simply take each piece and square it, so you don't have to do the subtracting 0, 0 for the starting point. 3 squared is 9 times 2 is 18. And when we simplify our radical, the square root of 9 is 3. 9 times 2 gave us the 18. So 3 squared of 2 is the simplest form for the magnitude of this vector. To find the direction angle, we can think about setting up a triangle. Here's our vector with x component of 3 and a y component of 3. We're looking for theta. Thinking about SOHCAHTOA, we have opposite and adjacent, which gives us the tangent of theta. In our case, opposite over adjacent is 3 over 3. This is a unit circle value. We do know where the tangent equals 1. In degrees, that would be 45. Example 2, we'll start off by finding the magnitude, multiplying the -2 by cosine of 240 will give us our x component. The cosine of 240 degrees, we're in the third quadrant on our unit circle. 240 degrees is a multiple of 60 degrees. Cosine goes 3 to 1, so we are at -1/2. Sine would be -3 over 2. Substituting those values in, and distributing that -2, we get 1i plus square root of 3j for our vector. This will help give us the magnitude and the direction. To find the magnitude, we'll put this in component form. Our x component is 1, the multiplier of I, and our y component is the square root of 3, the multiplier of j. Finding the magnitude of vector v, substitute those into the distance formula. 1 squared plus the square root of 3 squared gives us 1 plus 3, or 4. The magnitude of this vector is 2. To find the direction angle, we need to know where this vector is heading. Because of that scalar multiple of -2, it is not heading in a 240-degree direction like it might initially seem because of those angles being put in for the sine and cosine. Ours is in the first quadrant, heading towards 1 square root of 3. Using our tangent again, because that gave us both the x and the y component. Our x component is 1 and the y component was square root of 3. To find the direction angle, we set up tangent of theta equals opposite over adjacent. This is another unit circle value. Where is the tangent equal to square root of 3? That would be at 60 degrees. Example 3, we're given the magnitude and direction angle. We need to put it into component form. An angle of 330 degrees would put us into the third quadrant. Cosine is square root of 3 over 2. Sine is -1/2. Component form for vector v will be the magnitude of v times cosine of theta sine of theta. Magnitude of vector v is 9/4. Cosine of theta we just found to be square root of 3/2. Sine is -1/2. Distributing that 9/4 will give us our component form in its entirety. We have 9 times the square root of 3/8 and -9/8. Next, we're going to take a look at a couple of examples that don't fall on the unit circle exactly. Our first one, we have a component form of -3, 4. To find the direction angle, we will again set up the tangent. -3, 4 would be in the second quadrant. So our tangent of theta would be opposite over adjacent 4/-3. Because this is not on the unit circle, we will take the tangent inverse of both sides and punch that into our calculator to get our angle of theta. Our calculator gives us a -53.1 degree angle. Because our direction angle has to be positive, we have to think about where that is on the unit circle and how to get that positive angle instead. Remember, tangent has a period of 180 degrees, so if we add 180 degrees, we will get a positive angle in the second quadrant where our vector is. We get 126.9 degree angle for our direction angle. Similar to an example we just saw, we're given the magnitude and direction of a vector and we need to find the component form. Because it's not on the unit circle, we'll simply punch this in our calculator. To find our vector v, we take the magnitude of v times cosine of theta sine of theta. Since we don't know what theta is, we will have to use tangent in order to find theta. Our component form or our direction is -1, 2. Taking tangent equals opposite over adjacent, we're taking the tangent inverse of -2 to get our direction angle. Once again, we're given a negative angle, 63.4 degrees. So adding 180 to it to get our positive direction angle gives us a total of 116.6 degrees. Substituting that in for theta, we have the magnitude of v is 2 times cosine of 116.6 degrees times the sine of 116.6 degrees. Using our calculator, we're simply going to multiply 2 by the cosine of 116.6 degrees to get our x component, and 2 times the sine of 116.6 degrees to get our y component. Our x component is -0.896, and our y component is 1.788. Here are 2 U-Try questions. Please come to class with these attempted so we can start our time productively.